Welcome to the Math Help channel. Today's video I will discuss how to solve quadratic functions using completing the square. I will go through the process relatively slow, and once I get through that I will do a few examples as well as derive the well-known quadratic formula. So I guess there's not much then to go right to it. Okay, so this is going to be our first example. I'm going to assume you know how to at least solve quadratic functions as well as manipulate terms and things like that. So I'm just going to go ahead and jump right to it. Our first example is x squared plus 6x plus 1 equals 5. As far as completing the square is, the idea behind it is you want the left side to be a perfect square. Okay. So the idea here is what we're going to do is we're going to isolate our constant terms and our variables, meaning we're going to have our variables on this side. You want the variables on the left-hand side. You want your variables over there, and you want your constant terms on the right-hand side. So the idea here is you want to move. We're going to end up moving terms from one side to the other. So starting first of all, so that means we're going to have to move the 1 to the right-hand side. So first, we're going to subtract 1 to both sides. So what that leaves us with on the left-hand side is x squared plus 6x. And then we're going to leave a little bit of space, and I'll show you why. On the right-hand side, we have 4. So to excuse me. The reason we left the space is because we're going to end up putting something right here. We're going to add something to right there that makes that left-hand side a perfect square. That's the goal. So what we're going to do is we are going to, here's the purpose. You're going to take this number right there, not the variable, that number right there. And what you're going to do is you're going to take that number, in this case it's 6, and you're going to divide it by 2. And in this case it equals 3. And you're going to take that number and you're going to square it. In this case it is 9. Now if you remember the rules of algebra, what you add to one side, you have to add to the other. So now now I can rewrite our new polynomial down as x squared plus 6x plus 9 equals 13. Now do not move the 9 back over, because what that does is it takes you back to the original problem, or it takes you back to this step right here, and that's not what you want. So next we are going to factor this. Okay? So let's factor it. The easiest way to do this, now, when completing the square, this term right there, that will always be 1x squared. Always, 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 always. And I'll do a case when it's not. So it's going to always start off with an x, and it's always going to be a perfect square, hence completing the square. And what goes here, what goes right there, is this right here, that number right there. So whatever 6 over 2 was. If you remember what that was plus 3. And you can check it by foiling it out. And that equals our 13. Now you should have some experience in solving quadratics using the square root method. Otherwise you would not have learned completing the square by now. So to solve this, we just take the square root of both sides. what happens is when you take the square root of a term that is squared, those terms cancel. So you are left with x plus 3 equals, when you take the square root, on the right-hand side, there's a plus and minus. You cannot forget that. And that equals plus and minus square root of 13. So what's going to happen now is all you have to do is just move this 3 to the other side. And so what's going to be left is x equals negative 3 plus or minus square root of 13. And that's your answer. Okay, let's try one that's slightly more difficult. So, okay, our next one's going to be 2x squared plus 3x minus 1 equals 0. Okay? The goal here, like I said before, is you want to isolate your constant terms, the terms without variables. You want to isolate your variables and terms without. So, first, x squared, like I said in the last problem, has to be equal to 1. So, now in this case, it is not. What we have to do is we have to divide everything by 2, even if some of the terms are not divisible by 2. So now we are left here with x squared. Over here we're left with positive 3 over 2x minus a half equals 0. That looks disgustingly atrocious. I know. Bear with me here. Using the steps in the last problem, we can factor the perfect square that comes out of this very easily. Okay. So step 1, you move the next step is we're going to move that 1/2 to the other side because that's our constant. X squared plus 3 over 2x, leaving some space, equals 1/2. So what we're going to do is we need to add a number here. And what that's going to be is going to be, remember, it's half of the middle term, so it's going to be half of that. It also works if it's negative, so just bear with it. It doesn't matter. That last term will always be positive because even if this term is negative, the term that I have in red over there, if it is negative, when you square it, it'll become positive. So we're going to do 3 over 2 divided by 2, which is the same thing as saying 3 over 2 times 1/2. Okay? So then and we'll give you guys a little chance to remember that. I have to write that down. All right, and so that's going to equal 3 over 4. Now we square it. You guys can't, if it's still a little hazy, go back to the last example and review it. And when you square a fraction, all you do is you square the top and you square the bottom. And so what you're left with is 9 over 16. And that's what's going to go right there, as well as right there. Okay, almost done. So now what we do is we're going to square this right here, or factor it as a perfect square. So go ahead and factor it. If you remember, that first term is always going to be x, and since we're factoring as a perfect square, that will always be squared, and it is whatever it was before you took the square root, before you squared. So it's this number right there. That's what's going to go right here. 3 over 4. And then now what we're going to do is put on the other side, we need to add these together. So if you remember that 1/2 of the common denominator, that's going to be 8 over 16 plus 9 over 16. That's going to give you 17 over 16. Now we take the square root of both sides to get rid of this, of that squared right there. That goes away, and we're left with a plus minus. Now what happens is we're now left with x plus 3 over 4 equals, we don't know what the square root of 17 is, so we're just going to leave it as plus minus root 17 over, and the square root of 16, you all should know, is 4. Now we can just subtract the 3/4 to both sides, and we are left with x equals, and since they both have the same denominator, I'm just going to write them together. So we get negative 3 plus or minus square root of 17 all over 4. This method is used primarily when you are writing conic sections in their standard form when you're given their general form. I personally use this method aside from the quadratic formula because I think it's faster. Okay, so now that you've seen a couple of examples with fractions, with leading coefficients that are not 1, so on and so forth, and so we're going to try one more. In this one, as promised, I'm going to explain how the quadratic formula was derived. As I said before, it was derived using completing the square. Now that you've seen a couple examples on how the process works, I will go ahead and go through that derivation for you, just as an example, rather more complicated example. So, if you remember that the standard form for a quadratic is, whoops, that didn't work out. Okay, ax squared plus bx plus c. And since we're solving for x, we're going to set this equal to 0. All right. So here we go. Here's how this works. So what I'm going to do first is, if you remember, we have to move c to the other side, any constants to the other side. So you have ax squared plus bx equals negative c. Remember, a, b, and c are just fractions or whole number constants, so just keep that in mind. All right, if you remember, a cannot be up front. There cannot be a leading coefficient, so it has to be 1. So we're going to divide everything by a. And what happens? Well, hold on. Let's write it this way so there's less confusion. Let's write it this way: a, and a. And what happens? What's left over is that a goes away, and we're left with x squared plus b over a x equals negative c over a. Now, what we need to do is have a number right here. Remember, it's always what we have to do is take that b over a, divide it by 2, and square it. And remember, when dividing by 2, it is the same exact thing as multiplying by 1/2. So we're going to do b over a times 1/2, and that's b over 2a, and then we have to square. That's what's going to go right there. That's what's going to go right in there. So then, and we get b squared over 4a squared. When you square everything, when you square a fraction, it's squaring the top and the bottom and everything there. So it's going to be b squared over 4a squared. Sorry, that's a little scrunched together. And remember, what you add to one side, you've got to add to the other. So b squared over 4a squared. Okay. Now, we can go ahead and factor the left-hand side. And remember, it's this term right here before it's squared. That's what goes inside. So it's written as parentheses x plus b over 2a squared equals, and then what we're going to do is we're going to take this and we're going to write them as a common denominator. common denominator here is 4a squared. So that means we can multiply the c by 4a, and this by 4a as well. And by doing that, we get negative 4ac over 4a squared plus b squared over 4a squared. Now notice that they have two, the denominators are exactly the same, so I can write them as one fraction. So that gives us, I'm going to keep the positive term first, so I get b squared minus 4ac over 4a squared. That should start looking familiar now. And I'm going to take now, remember, when you have that perfect square right on that left-hand side, we can take the square root. So we will take the square root, and what's left over is x plus b over 2a equals plus or minus square root of b squared minus 4ac. And remember, in the square root of 4a squared, well, the square root of 4 is 2, and the square root of a squared is just a. So it's 2a, and that should look familiar. And then all I have to do is now subtract the b over 2a to the other side, and then I am left with x equals, and if you'll notice that they will, let's see, we have negative b over 2a plus or minus square root of b squared minus 4ac over 2a, and notice that they have the same denominator. I can put them together, and when I do that, I get x equals negative b plus or minus square root b squared minus 4ac all over 2a. And there is our famous formula. If you have any questions about this topic, or if you have a topic you would like me to do a video over or a series of videos over, please leave me a comment or leave me a message, and I'll get back to it as soon as possible. Please subscribe. Thanks again for watching, and have a great day.